Hello kids, I hope that you have completed the exercise 1.5 and practice that on your own. So in today's class, we are going to move further in this chapter and we are going to see how the shape sequences or how these shapes they are related to the number sequences, right? A part of it we have already done in the previous exercise where we saw that how the regular polygons they were following the counting sequence, right? Similarly, the complete graph they were also following the counting sequence. The stacked squares and stacked triangles they were following the another sequence, which is your square sequence, right? So now, as a part of this concept of relation to number sequences, we are again going to learn that how the shape sequences are related to the number sequences. Okay, so what is written here is often shape sequences are related to number sequences in surprising ways. Such relationships can be helpful in studying and understanding both the shape sequence and the related number sequence. So, example is the number of sides in the shape sequence of regular polygons is given by counting numbers starting at 3, 4, 5, 6, 7, 8, 9, 10 and so on. So kids, we have already done this, that in the case of the regular polygons, the smallest polygon will have 3 as the number of side and vertices, and then it was increasing, right? And it was following the counting number sequence. The same has been written here. That is why these shapes they are called regular triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, etc. Right? So the number of sides in a triangle are 3, in quadrilateral is 4, pentagon has 5, hexagon has 6 and so on, and it is following the counting number sequence. And when we say regular means all the sides are equal and also these sides they are at equal angles with each other. That means the space between the two lines, are also same. The length of the side is same and the space between these lines, which we call as angles, they are also same. Okay. Now, I think we can start the next exercise now, that is exercise 1.6. So, the first question is, count the number of sides in each shape in the sequence of regular polygons. Which number sequence do you get? So, we have already done this. I am rewriting here. In the case of triangle, the number of sides are 1, 2 and 3. For quadrilateral, it is 1, 2, 3 and 4. Pentagon has 5. 1, 2, 3, 4, 5. Hexagon has 6 sides. 1, 2, 3, 4, 5, 6. Next is heptagon. 1, 2, 3, 4, 5, 6, 7. It has 7 sides. Octagon has 8 sides. Nonagon has 9 and decagon has 10. Okay. So, these are the number of sides in these regular polygons. Next is which number sequence do you get? So, it is a counting number sequence starting with 3. Okay. Now, what about the number of corners in each shape in the sequence of regular polygons? So, kids, we can see, we'll start with the triangle. This is 1, 2 and 3. So, the number of corners is also 3 here. This 3 is the side, comma, I am writing the number of the corners. Here it is 4. 1, 2, 3 and 4. So 4. 4 is the side, 4 are the corners. Similarly here 1, 2, 3, 4 and 5. I am writing 5 here. 1, 2, 3, 4, 5 and 6 here. It has 6 corners. This heptagon has 7. 1, 2, 3, 4, 5, 6, 7. Octagon has 8. We can count 9 and 10. So, we see here in the case of regular polygons, the number of sides and the number of corners, they are same and they are following the counting number sequence. Okay. Now, do you get the same number of sequence? Yes. And can you explain why this happens? This happens, the sequence which these sides and these dot follow are counting numbers. Okay. So that's why the sequence is also same. So in short, I'm writing the answer here. I have already defined the number of sides and corner in this figure, and what I can write here is the number of sides and the number of corners in regular polygon is same. Hence, they follow same sequence. Okay, they will follow the same sequence. That is counting number sequence. This is counting number sequence. I hope this is clear that in the case of regular polygon, the corners and sides are equal and they are following the counting number sequence starting from 3. I'm also mentioning here starting from 3. Okay. Now, let us go to the second question. It is count the number of lines in each shape in the sequence of complete graphs. Which number sequence do you get and can you explain why? So let us start this question. In the very first figure, we have one line here. We have to count the number of lines. So we have one line this. Here we have 1, 2 and 3. In this figure 1, 2, 3, 4 and then these diagonals 5 and 6. Next 1, 2, 3, 4, 5. Then 6, 7, 8, 9 and 10. So this is 10. And this must be, by now you should have understood that this is following a triangular sequence. This should be 15 and so on. Okay. So which number sequence this is following? It is following, this is following a triangular sequence. Okay. Triangular sequence. And that is, triangular sequence is 1, 3, 6, 10 and 15. Okay. Now, we can move to the next question. Next question is this one. Wait, I'll just move it a bit. Yeah. How many little squares are there in each shape of the sequence of stacked squares? And which number sequence does this give? Can you explain why? So, we are talking about little squares only. In the very first figure, we have one little square. In the next one, 1, 2, 3 and 4. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So kids, we know it is following which sequence? This is following the sequence of squares, right? This is following the sequence of squares. I'm writing here. Answer number 3 is, this is following sequence of squares. Okay, and that is 1, 4, 9, 16, 25, and so on. And we can also write this as 1 square, 2 square, 3 square, 4 square, 5 square, right? Because the small number of squares, they are increasing in a manner of square sequence. Next is our answer number 4. How many little triangles are there in each shape? Now we have to count the triangles in this image. Which number sequence does this give? Can you explain why? Okay, so I will just move it a bit. Yeah. Answer number 4 is little squares. 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 till here, and then 10, 11, 12, 13, 14, 15, and 16, and this must be 25. Okay, so which sequence this is following? Again, this is following a square sequence, right? This is following square sequence. Like above, 1, 4, 9, 16, and 25. And we can write this as 1 square, 2 square, 3 square, 4 square, 5 square, and so on. Okay, now why this happens? This happens because if you see, this was one triangle first. To this one triangle, we have added 1, 2, 3 triangles. Now, in this figure, these 4 already exist. To this, we are adding 5. And in the next, 1, 2, 3, 4, till this, these 9 already exist. And we are adding 1, 2, 3, 4, 5, 6, 7. So, if you see, we are adding a sequence, we are adding up the sequence of odd numbers, right? Here, I can write here, we are adding up the sequence of odd numbers. Okay, this is a sequence of odd numbers. We are adding 1 plus 3 plus 5 plus 7 and so on. And in the earlier exercise of this chapter, we have already done that if we add up a sequence of odd numbers, we will get a sequence of squares, right? We have already done this. So I'm writing it here. Yeah. When we add up the sequence of odd numbers, we get sequence of squares. Okay, they are related this way. This we have done. So that's the reason we are getting a sequence of squares here. All right, again I'm telling you, see, we know that this image has one triangle. It has 4, 9, 16 and 25, and we can easily see that is a sequence of squares. But now why it happened? Because here to this one triangle we are adding 3 more triangles, that is 1 plus 3. To this 3 triangles, I mean this 1 plus 4, we are adding 5 more. It became 1 plus 3 plus 5. To this 1 plus 3 plus 5 triangles, we are adding 7 more triangles in this last row. Okay, so with each image, we are adding the odd number of triangles to it. Okay, so hence we get a sequence of squares, because when we add up the sequence of odd numbers, we get the sequence of squares. I hope this is clear. Now, I will move to the last question of this exercise, answer number 5. It says to get from one shape to next in the Koch snowflake sequence, one replaces each line segment by a speed bump by this triangle. We did this, that we have to, in every side we have to make this 1, 2 and 3. Then we will erase this. It will become like a root bump. As one does this more and more times, the change becomes tinier and tinier, which we can easily see. It is very small, it becomes very tiny because it gets filled with lot of these bumps. How many total line segments are there in each shape of Koch snowflakes? What is the corresponding number sequence? Okay, so this question we have already done in the previous exercise also, where we saw that the number of side in the very first one is 3. Okay, to get the second shape, what we are doing is we are multiplying this by 4, or you can say by the power of 4. So this one I can write 3 multiplied by 4 raised to the power 0. Second shape will 3 times 4 power 1, 3 times 4 raised to the power 2. This one is 3 times 4 raised to the power 3. This one is 3 times 4 raised to the power 4, and so on. Right? Similarly, it is also written over there. The answer is 3, 12, 48. That is 3 times the power of 4. Okay? This one. This is the thing. So what I am writing here is, I am writing again in Koch snowflake. In the Koch snowflake, we follow a power of 4 sequence. We follow a 3 multiplied by power of 4 sequence. That is, the first one we have 3 into 4 raised to the power 0, which will give us 3, because 4 raised to the power 0 is 1. We have done this. Anything raised to the power 0 is always 1. So 3 multiplied by 4 raised to the power 0 means 3 multiplied by 1, which give us 3. Next number is 3 multiplied by 4 raised to the power 1, which will give us 12. Next, so in the next figure we will have 12 sides. Then we have 3 multiplied by 4 raised to the power 2, which is 48. And this will go on. This is how we are going to get a Koch snowflake sequence. And these sides, they will become tinier and tinier. Alright. So I hope this is clear. As a part of this, we have seen that how the shape sequences, they are related to the number sequences. We have seen that the first one follow the first the regular polygons. The regular polygons, they follow counting number sequence starting with 3, and each image they have equal number of sides and equal number of corners. Okay. Next, we did the complete graph, which also in the complete graph we have seen that it follows a triangular sequence when we join the number of lines here for the number of lines. But if we see the dots, if we see the corner, then it will follow a counting number sequence. Okay. For the lines, it is following triangular sequence, but for these corners, these points, we are following the counting number sequence starting with 2, which we have done in the previous class. So don't confuse. There we were talking about the corners, and here we are talking about the lines. Okay. Now, next one here is the square sequence. So in this square sequence, we can easily see it is 1 square, 2 square, 3 square, 4 square and 5 square. So they are following a sequence of squares. Next, we have the stacked triangles, which is also following a sequence of squares. How? By adding up the odd numbers. In the first one, we have 1, then we added 3, and then 5, and then 7 and 9. And we have seen that when we add up the sequence of odd numbers, we get the sequence of squares. And the last one, we have the Koch snowflake. Here we have seen that it is following 3 times the power of 4 sequence. Okay. In the very first figure, we have 3 sides, which we can write as 3 multiplied by 4 raised to the power 0, which is nothing but 1. So it has 3 sides. Next, we have 3 multiplied by 4 raised to the power 1, that is 12 sides, and it goes on. Okay, kids. So this brings us to the end of this chapter, end of this exercise, and end of this chapter. And now in the next class, I will pick a few questions from R.S. Aggarwal, and we will see that how we have to do those questions. Okay. So kids, this is the end of the class, and I will see you in the next class.